When a tank is exposed to sustained heat, such as from a fire, the liquid within the tank is forced to boil or vaporize, resulting in increased pressure in the tank. To prevent overstressing the tank, the relief device activates, venting the excess pressure. As pressure decreases in the tank, the valve begins to close. With continued heating, pressure again builds, causing the relief valve to reopen. Where flames impinge on the tank below the liquid level, the liquid absorbs the heat, allowing the tank metal to remain at a safe temperature. With continued relief valve operation, the liquid level drops, exposing a greater area of the tank to the effects of heating. With the flames impinging on the vapor space of the tank, the temperature of the tank metal, uncooled by liquid, rises. At some point, due to the vapor pressure from within, the tank metal begins to weaken, stretch, and eventually tear. As the tank comes apart, large quantities of both liquid and vapor are released in a powerful explosion. The heat radiated is sufficient to ignite combustibles and cause burns great distances from the explosion. Tank sections containing rapidly igniting fuel can become flying missiles, traveling great distances, causing secondary fires and other damage. It all happens quickly and with little warning.